Let's go ahead and take a look at number 4. So we're looking at division here, and we're saying that we have two mystery numbers here. We don't know what, at least yet, but two numbers that divide. When you divide them, you end up with a -4 as the outcome there. All right, so let's think about things that would divide. I'm kind of drawn to the biggest number here first. 24, and then I would say, well, 24 divided by what, right? When you're dividing, you're making it smaller here. 24 divided by 8 would be 3. 4 doesn't go into 24 evenly. Oh, okay, how about 6? And so if I took a look at 6, 24 divided by -6 would give me -4. And part of the reason what we wanted to see here, it says using your solution show how division is just the opposite of multiplication. What we mean by that, let me circle my answer here, 24 and -6, is that when we're saying 6 goes into 24 4 times, another way to think of that is that if you looked at it from left to right, this says 24 divided by -6 equals -4. But if you looked at it in reverse, if you said -4 times -6, so -4 times -6, you get a positive 24. And looked at the other way, because we said that multiplication is commutative, we could have also said -6 times -4, which would give you 24 as well. So we're wanting to kind of see two things with this. One, again, that multiplication is commutative, meaning that the order doesn't matter, you get the same answer either way. And the other thing is that to see this relationship between division and multiplication. Alright, so as the other problems, there's actually two possible solutions we could come up with. And so let's see, what else could we divide? And again, it's kind of a trial and error. 6 divided by 2, 2 goes into 6 3 times, so we're looking for 4. 4 goes into 8 2 times. Oh, but 2 goes into 8 4 times, so that would work. So we could say -8 divided by 2. And then the way we can kind of check our work on that is, let's do it in reverse. -4 times 2 is -8. Or if I switch that around, 2 times -4 would also be a -8. One thing we should mention about the signs here is that with multiplication and division, it's a separate set of rules than it is for adding and subtracting. So I think the real easy way to remember this is, do you have the same signs? If you do, it's going to be positive. If you have different signs, then it's going to be negative. So don't think so much about, oh, which one's bigger, which one comes first. None of that stuff matters. Same signs positive, different signs negative. So they have different signs, so our answer would be negative there. A kind of proof of that, by the way, again, go back to our idea of multiplication being repeated addition. So what we said here, for instance, is that if we said, let's say -4 times 2, what that means is to take -4 and add it 2 times. So -4 plus -4 is equal to a -8. Right? So that's how we're kind of able to prove that. Alright, so go ahead and pause now, try 4.2 and 4.3, and we'll come back and check the answers. Alright, let's check them. 4.2, again, two possibilities here. -8 divided by 4 would give you -2. The other possibility there, 10 divided by -5 would also give you -2. And for 4.3, 12 divided by -2 would give you -6. And 18 divided by -3 would also give you a -6. Division, however, is not commutative, right? So the order does make a difference there. There is a difference between saying 12 divided by -2 and -2 divided by 12, right? So 12 divided by -2, yeah, that's -6, but 12 doesn't go into 2, right? The number on the bottom, the denominator, is larger than the number on top, the numerator. So that's actually a fraction. Now you can reduce that fraction and you get -1/6. But so you see that 6, -1/6. So division is not commutative, and subtraction as well is not commutative. Alright, so we'll go ahead and stop here and move on to the next problem.